Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about how you can prove that the mean and variance of a negative binomial random variable given as such. And in order to do that, we need to use the results derived in example 5.5. And this example has already been discussed in the previous video. And the results here are related to the value of ex. Okay, so if x has a geometric distribution, so x has a geometric distribution, therefore the results here are related to having expected value of x equals to 1 over p and variance of x is equal to 1 minus p over p squared. And these are the results derived in example 5.5. And we also need to use this fact where the sum of independent geometric random variables has a negative binomial distribution. So we are going to use this fact and these results here in order to prove that the mean of a negative binomial random variable is this one and the variance of a negative binomial random variable is given by this one right here. Okay, but before we can go on, let me just explain the meaning of this statement given here. Well, recall what is a geometric random variable. So geometric random variable is when you have a geometric random variable, I'm going to call it x. X here represents the number of trials when the first success is observed. Okay, so when first success occurs. Okay. On the other hand, if we have a negative binomial random variable, so if we have a negative binomial random variable, and for clarity, let me just use another alphabet to represent the random variable. I'm going to use y. So y here represents the number of trials when the kth success occurs. So if you think about it, let me just give you an example. Let's say you are interested in the situation where you want to find number of trials when third success happens, let's say. So the process of having the third success is similar as having geometric random variable, one geometric random variable, x1, that represents the first success, and then x2, which is also a geometric random variable that represents another first success, and the same thing as having the third geometric random variable. Again, geometric random variable is the number of trials when first success occurs. Okay, so if you are interested in this, this is actually a negative binomial random variable. You're interested in y here, where y is the number of trials when the third success happens. This is the same thing as looking at it separately by focusing on three different geometric random variable. For this one represents one success. For this one also represent another different first success, and this one is another first success. When you add them up together, you will get the number of trials when the third success happens. So that's the idea. Okay, so I hope you can see that. Therefore, we're going to use this statement here in order to derive the results that are given in this position, these two results here. Okay, right. Okay, let us start with defining what is our negative binomial random variable. So in this case, our negative binomial random variable can be written as, for example, y. So y is the result of the first geometric random variable plus the second geometric random variable, and we're going to keep on adding it until the kth geometric random variable. Why do we stop at k? Because recall that in a negative binomial distribution, we are interested in the number of trials where the kth success happens. Kth successes. So here we're going to have separate geometric random variable up until xk. Okay. So we have this one first success, this is another first success, this is another first success, and we're going to have up to k, and then if you think about it, that will give you kth successes, right? So that's it. Okay, now we can then start with finding what's the expected value of y. So I hope you can see that this is the linear combination, and we have actually learned about finding the moment and the variance of a linear combination of variables in chapter 4. And if you don't recall, here are just some little notes right here. AI here is a constant right next to x, but our constant here is 1, so we don't have to do anything much really. So we're going to end up with finding expected value of x1 plus expected value of x2 plus expected value of x3, and we keep on doing that, and then we arrive at expected value of xk. And we are going to just apply the result here. We know that if x1 is a geometric random variable, then the expected value of it is going to be 1 over p. Similarly, x2 here is also a geometric random variable. Therefore, the expected value here is going to be 1 over p. So the results here are all going to be equal to 1 over p. And we know that this term here are all similar, and it happens k times. Therefore, the final result of it is going to be k times with 1 over p, and that can actually be written as k over p. This is similar to what you have seen right here. That's how you can find the expected value of y. Y here is a negative binomial random variable that represents the number of trials where the kth success happens. Okay, now we're going to move on to finding what's the result for variance of y. So let me just erase this part. Okay, so next we are going to look at finding the variance of y. So variance of y, so this is again the linear combination, and you can actually apply this formula right here, but our formula here is going to be simplified to just this part. This one we don't need to consider because the random variables given here are independent. So when they are independent, we are not going to consider the covariance part at all. So the formula here got simplified to just consider this variance part of each random variable x. Okay, and we also don't have any constant right next to x1, so that makes our life easier as well. Therefore, the variance of y can be obtained by considering variance x1 plus variance x2 plus variance x3 plus dot 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 variance for the kth random variable. And we're just going to apply this result because we know we have obtained, I have shown to you guys already that if you have a geometric random variable, the result is as such. So we can just use this result and apply straight away. So we have 1 minus p over p squared. This is also the same thing because x2 here is a geometric random variable, and we know that the variance of a geometric random variable is going to be this guy. So just write down the same result really. Okay. So we know that we have all this term which is similar terms, and this term are repeated k times because we have k different geometric random variable, right? And therefore this result is the same thing as having k times with 1 minus p over p squared. And what we can do is we can try to change the representation of it so that it looks like this one. So that becomes, you can take out p, so we have k over p, 1 minus p over p inside here, and that can be written as k over p, 1 over p minus p over p, which is equal to 1. And you are able to show that the variance of a negative binomial random variable is given by this formula. Okay, I think that's all for now. Thank you very much for watching.